Welcome to part 3 of my Seedling and Sensors series. In part 1 and 2 of this series, I planted my vegetable seeds and discussed the Arduino and the different sensors I plan to use in this garden habitat monitoring prototype. In this video, I'll be adding the sensors to my seed starter set and monitoring the data as it flows from the sensors to the Arduino out to my Java microservice API running in a Docker container and then making its final resting place in a MySQL database. I'll briefly touch on the code I used to create this sensor data pipeline, and I'll demo a couple of applications I can use, Jupyter notebooks and pandas, to peek into my data to see what's going on. I added links to the code I used as well as links to the different applications in the description, so you can check them out there. Adding the sensors is easy. I just place the soil moisture sensor down into the soil and place the temperature and humidity sensor on top of the cells. Once I cover the cells with the humidity dome, I can plug in the Arduino and it should start sending data. One thing I need to point out, I'm using the Arduino Uno Wi-Fi board here. This board will send HTTP requests to any web address you specify in the code. When the sensor data is read by the Arduino, it will post that information to my Java microservice API running in a Docker container on a laptop that I've loaded with Ubuntu and connected to my home network. You'll see here I've cleared the data from my database, so I receive no records when I query the soil sensor reading table. I set the code in the Arduino to post sensor values to this table every minute. The way the prototype habitat monitoring system is set up is as follows. The sensors take the moisture, humidity, and temperature readings. Those readings are relayed to the Arduino. The Arduino Wi-Fi then constructs a JSON payload and sends a post request off to my Java microservice API running in Docker on my networked laptop. The API then transforms the JSON payload into an object model and uses Hibernate to insert this data into a MySQL database, which also runs in a Docker container. I've set up a volume on the local file system of the laptop instead of letting this reside in the same container as the MySQL database. This is so that if that container running MySQL crashes, I won't lose the data when the container is recreated. Finally, if I want to look at my data to perform some analysis, I can use a cool tool named Jupyter notebooks and pandas and write Python code to run queries, load the data into data frames, and generate statistics and graphs to gain a better understanding of how my environment is behaving. I'm not going to go through the code line by line since that's outside the scope of this video, but I will briefly show it to you and let you know that links to the code are provided in the description. The first piece of code is the Arduino and sensor code. This is very similar to the code I discussed in the second video in this series, except here I am constructing HTTP post requests with a JSON payload and sending this to a web address for processing. There's a ton of tutorial videos on YouTube and in blogs on the internet that go into great detail about this particular set of instructions with the Wi-Fi and networking library, as well as specifics about the sensors. Definitely check those out if you're interested to learn more. The next set of code is with the Java API used in conjunction with the Spring Boot framework. This contains a controller to process requests, a service layer to perform any business logic or extra pre-processing before it gets stored in the database, and a repository layer for shipping this data off to MySQL. I also used Hibernate as an ORM since I'm performing basic CRUD operations with the database. In addition to this Java code, I wrote a SQL script to create a user and table needed to store this data. As I mentioned earlier, the API and database both run in Docker. I have a Docker file which pulls a slimmed down version of Linux and adds my API jar file into the Docker image file system and sets a command to be run to start the API when the container is created. I also used a tool called Docker Compose, which helps to orchestrate my services running in containers. There's a Docker Compose file that I run to build my API and MySQL images and start containers. All of these files are in the same project. Since my sensors have been running for a few weeks, I've been able to collect around 23,000 records of humidity, moisture, and temperature readings. It's not a ton of data, but enough to get an idea of the environment in which my seedlings have been growing. A neat tool you can use to better visualize and generate statistics on your data is Jupyter notebooks. It's relatively easy to install and not that difficult to use. You also code with Python, which is a plus. There are a few libraries that are great for working with data, and one is Pandas. It enables you to create data frames which you can use to transform, query, and manipulate to get your desired results. Here I'm able to load data from the MySQL database soil sensor reading table and load it into a Pandas data frame. From there I can run commands like describe, which generates a set of statistics about my data set, such as standard deviation, min and max values for each column, the mean, and even quartiles. You can even generate statistics on individual columns of the data frame with the describe method. For instance, here we see that I have an average of about 96.4% humidity in the environment. And for temperature, we had an average of 22.2 degrees Celsius, which is about 71.6 degrees Fahrenheit. Another great tool you can use with Jupyter notebooks and Python are the plotting libraries like matplotlib. With this library, you can easily visualize your data. Here I am creating a simple line chart to visualize the moisture readings over the course of the lifetime of the seedling environment. I set the x-axis to contain the column reading date and the y-axis to be my moisture readings. It's that simple to generate a chart using matplotlib. I can then reuse this code and create a chart for humidity and temperature as well. Thanks for checking out this video. Don't forget to subscribe to my channel and to look for my next video where I transplant my tomato seedlings to larger containers and begin to harden them outdoors under natural sunlight. Take care, everyone.